Hello everyone, welcome for DMS lecture. Previous lecture we have seen the theory related to multiple speed gearbox design, where we have seen different laws of progression, then speed diagram, structure diagram, ray diagram. So the different diagrams which can give us a different information that we have seen in our previous lecture. In this lecture, we are going to discuss the basic procedure and we will learn with a simple example. Okay, so let's see first procedure. We need to adapt a following procedure while solving the design of multi-spindle gearbox. First step, write down the input data. So minimum diameter of workpiece to be machined, D minimum, and the corresponding maximum cutting speed, that is Vmax, that should be mentioned. Then the maximum diameter of the workpiece to be machined, D max, and the minimum diameter for corresponding minimum cutting speed, V minimum, that should be, you have to give that much inputs. Next, we need to calculate the maximum and minimum spindle speed. Okay, so Nmax you can calculate by equation 1000 into Vmax divided by pi d minimum, and minimum speed you can calculate with the equation 1000 into V minimum divided by pi into d max. So the calculation of the speed is important because they plays an important role while calculating the other parameters. Third step, to calculate the range ratio of the spindle speed, that is a RH, which is nothing but the ratio of R max divided by R minimum, which we can say a transmission ratio also. So it gives the actual transmission ratio, that is also here it indicates with the range ratio of the spindle speed. Fourth one, we need to select a geometric progression ratio, that is a phi. Fifth step, we need to calculate the total number of spindle speed steps, that is Z. So Z we can calculate log of Rn into phi divided by log of phi. By equation, we can calculate the number of spindle speed steps. Sixth step is the list of all the spindle speed from minimum speed to maximum speed we need to list down. Seventh, decide the number of stages, that is a transmission group, which we have discussed in a previous theory lecture, that is a 2 into bracket 1, 2 into bracket 2. So in such a manner we need to decide a transmission group. Then write the structural formula and construction corresponding structure diagram. To write the structural formula we need to use equation Z is equal to P1x1, P2x2, P3x3 up to the Pnxn. Then we need to draw a structure diagram. The next, select the electric motor speed, which we have to supply the basic input speed, that is a electrical motor speed. It can be ranged from 1440 rpm to 50 rpm, 3000 rpm. So it's depend which motor you are going to select. Normally 1440 rpm motor is we are using. 10th step, to construct the spindle diagram, a speed diagram. The construction of the speed diagram based on the structure diagram. Then last step, construct the kinematic diagram for a gearbox. Okay, here we are actually showing the gear arrangement. Okay, so let's see with the problem. In December 2019, for 20 marks, this question is asked. It is required to design 2x3 multiple spindle gearbox for a lathe machine operating with the following specification. Minimum operating spindle speed is 120 rpm, motor speed is 1500 rpm, geometric progression ratio is 1.41. What we have to find out? First, write the structural formula and draw the structural diagrams. Second, draw a ray diagram and speed chart. Third, find the number of teeth of each gear. And last one, draw the deviation chart. Okay, now this deviation chart is gives an exact speed and number of teeth on gear. Okay, we will discuss it later. So just start with the writing down the given data. Minimum speed, that is N1, is equal to 120 rpm. Motor speed, that is N motor, 1500 rpm. Geometric progression ratio GP, phi is equal to 1.41, and 2x3 multi spindle gear box. So we need to find out number of steps. So 2 into 3, that is equal to 6. So Z is equal to 6. Total number of steps are 6. So first we need to calculate the different spindle speed. Okay, so as there are 6 standard spindle speed on the output shaft, that can be calculated as follows, because we have a progression ratio. So N1 is equal to minimum speed, that is 120 rpm. N2 is equal to N1 into phi, that is 120 into 1.41, which is 169.2, which is equivalent to 170 rpm. N3 is equal to N2 into phi. So similarly, N3 we can find 240, N4 that is 340, N5 that is 480, N6 that is 680, and the N motor is equal to 1550, because they don't provide the maximum speed in the given data. Okay, so whatever the speed you reach at N6, that is a maximum speed that can be we need to required for machining. Now draw the structural diagram. Okay, so it is very important to select a proper structure diagram. Okay, for how we can draw a structural diagram. Now here look at the figure number 1, that is structural diagram. So here to check the stability of the range restriction, that is Ig is equal to phi raised to x, which is lesser than 8. It is a necessity of the that is a range restrictions. So here we need to consider Ig, that is a spacing between two outputs. Spacing between two outputs should be, we have to decide. Okay, how we can decide? Let's see. So first of all, how many outputs that we need to first mark down? Okay, so as we know that there is a total outputs are 6. Okay, so we need to write down appropriate values based on that. Okay, so first of all, draw. We will start how I can show you how to draw. Okay, so first of all, draw these 3 lines. Sorry. Okay, let's start with the one by one. First of all, draw these 3 lines. That is a step number 1, step number 2, and spindle number 3. This is a spindle number 1, spindle number 2, and spindle number 3. So this is an input spindle, this is an output spindle, and this one is a intermediate spindle. Okay, so first of all you have to draw that much. Okay, so what is the combination of 6 we can find out, 2 into 3. Okay, so in a first stage we need two multiple spindle what you can say, two multiple outputs, speed outputs. So initially we had a single input. Okay, from input we have a single input. Okay, so from that we need to find out two outputs, as two value is indicated, that is a number of outputs. Okay, but what is the distance between, or what is the spacing between these two outputs? That spacing is indicated over here into bracket. X is equal to 1. So with respect to the scale, I have considered this, that much distance is equal to 1 spacing, that much distance is equal to 2 spacing, that much distance is equal to 3 spacing. So based on the lines I have making the scale. So here you can see appropriately that the scale or spacing between these two outputs are, or these two points are 1. Okay, so these are the 2 points, first and second. Okay, so this is a stage number 1. What is in the second stage? Second stage, we need 3 outputs. We need 3 outputs because 2 into 3 is equal to 6. Our ultimate number of output speed are 6. So 2 into 3 is equal to 6. Okay. Now what is the spacing? The spacing between these are 2. Okay. So first of all, draw a single line at the end. Okay. I have drawn over here. Okay. What is the spacing? 2. So this is the 2 spacing. Where is the second point? This is the second point. Okay, I am drawing the second line. Okay, so first point, second point, we need third point. So again, draw 2 spacing. Again, here to here, spacing 2, we need this point. Okay, draw this line. Okay, so in this manner, first, second, and third, we get proper 3 outputs from this single input. Okay, now similarly we need to draw for second one. So here the second output is over here. So drawing first line which is parallel to the 1. Okay, I indicates it's an A. Okay, the spacing between A and next point is 2. So you can draw spacing this much. You can get a point number 2 over here. You can draw a line to connect this point. Okay, so you get point B. Now next one, we need to draw a last point. That last point having spacing B से उसका 2 का spacing है, तो ये spacing मैंने डाल दिया. I have selected this point. Okay, so I connected this point to this point. What we get? Point number C. So total, how much outputs we received? 1, 2, 3, 4, 5, 6. So total 6 outputs we have received. Okay, I hope everybody is understood the process, how to draw a structure diagram. It's very easy because it's totally depend upon this formula. Okay, so based on this formula, you can easily draw a structural diagram. Okay, next, to check the stability, we have already find out the equation. For the structural diagram, the maximum value of Ig occurs in stage number 2. So that is a maximum transmission ratio, Ig, it is occurred in stage number 2 because there are various changes. In stage number 1 only 2 outputs are there. In stage number 2 there are 6 outputs. So the variation in a transmission will be occur maximum in stage number 4. So Ig 5 raised to 4. So 1.41 raised to 4 is equal to 3.95, which is lesser than 8. Hence, the value is less than 8. This diagram is suitable diagram. Okay. Now next, to draw a spindle diagram, speed diagram. So this diagram gives the actual data of the RPM, or you can say spindle speed of the stage output stage. Now, by considering the optimum design principle, we need to draw a ray diagram. Okay, you can say a ray diagram or speed diagram. Both indicates the same values. Okay, how we can see? To drawing this diagram, we need to first draw a sample line, which we can see a motor line. Okay, here it can shows, this line can shows a motor speed, that is a motor shaft. Then shaft number 1, shaft number 2, and shaft number 3. Okay, so first one, this is a motor shaft, this is a first shaft, this is a second shaft, and this is a third shaft. Okay, now let's start with the values. So values we have already calculated. Annual is equal to 120. Okay, so 120 I have started to draw based on the same process. Okay, so first of all, I have just noted first point. From first point, what is the spacing? That spacing is we know that is 1. So this is the 1 spacing. Okay, so these are the 2 outputs. These are the 2 outputs as a spacing is equal to 1. In stage number 1, that is from spindle 1 to spindle 2, the spacing between 2 outputs are 1. Okay, now about stage number 2, from spindle number 2 to spindle number 3. From spindle number 2 to 3, from each output there are 3 different outputs. Okay, as per we have already seen in above structure diagram. Now again we have to draw similar manner. So drawing first line, this is a first line, I get first point. Then the spacing between these are 2. Okay, so drawing second line, I get second point. Again the spacing between is 2, so I draw this line to over here, I got third line. So these 3 points I can reach, or I can find out these 3 speeds from this single output. Now we need to find out another 3 speed. So I'm referring this point now. Okay, so first I have drawn same way because it is an empty one. So I drawn first point over here. Then spindle speed spacing is 2. So this is a 2 spacing. I got this point. I can connected this from this to this. Okay, again spacing is 2. So connecting 2 spacing, we received this point. So connect this from this to this. Okay, so you can achieve these 6 different output speed. Okay, now how to write the RPMs, because we need to indicate the RPM as the lower RPM is in a bottom direction, bottommost position. So we are writing, while writing the values of speed, you can start writing from over here. So the smallest speed is at low, then you can increase the value of the outputs. So the 6 outputs which we need to fit on the strict speed diagram, that is shown over here. Okay, So from the speed diagram, it can be seen that in the last stage, the speed reduction from one of the gear pair would be from 480 rpm to 120 rpm. Okay, 480 rpm to 120 rpm, and in other way 680 rpm to 170 rpm. Okay, so here they have we need to calculate, or we have to understood the speed which is formed at the second stage. Okay, look at here, this is a 480 line. Okay, and here the 680. So in a stage number 2, what how much speeds are received from the this one is a 1500 rpm. Okay, this is a 1500 rpm. So in stage number 1, they have some reduction from this point to this point. This is a 680, so the value of this point is 680, and value of another point is 480. Okay, so first point, from stage number 1, in stage number 1, the 100 and 1500 rpm is splitting into two speeds, that is a 480 rpm and 680 rpm. Now from 680 rpm we get 3 points. First 680, second 340, and third one is a 117. Okay, from 480 we get 3 points, that is a 480 rpm, then 240 rpm and 120 rpm. Okay, so in this manner you can split it all. Okay, so when we find out the reduction ratio, uh, that is 480 divided by 120, so reduction ratio is near about 3, so it is very less than 6, so we can use here per gear. Okay, now drawing the layout, it is very important to draw layout in a proper manner. So first need, in the first stage there is two variations. Okay, only the input is given through the motor. So we have drawn a single shaft, this is a motor shaft. Okay, so motors, from motor shaft what we get, only one input is there. So here the gear is arranged in a proper manner, in that manner. Okay, and variation there, we need to only two, in single stage there is only two outputs. So this is a first output and this is a second output, so that's why we are selecting these two gears. Okay, in second stage we need 6 output in a proper manner. Okay, so here you can find out different gears. So first, second, third, fourth, fifth, and approximately when you changes the gears you can get a sixth one. Okay, so here when you draw, just a minute, when you start with the drawing, the structure layout of gearbox, this is a sliding gear. Gear number B is a sliding gear, which is indicated by this arrow. This is one is a constant gear, small a. Small a is connected with the A dash, B is connected with the B dash, C over here, C is connected with the C dash, D is connected with the D dash, E is connected with the E dash. So in this manner, the different gears are arranged. There are only two sliding gears, gear number D, which is a sliding one, and gear number B here, which is a sliding one. Okay, so B, all the remaining spindles gears are stationary gears. Only these two gears are move, and uh, these two segments are move, and they can achieve appropriate speed range. Okay, so simple arrangement I have shown here: motor shaft, then output shaft, then either here I have shown the pulley arrangement. Here is the motor is connected. Okay. Now decide the number of teeth on gear in stage number 1. Okay, to determine, just observe this diagram properly because we are using same annotation and same transmission ratios for further calculation. Okay, now to decide the number of teeth on gear in stage number 1, that is a ZA, ZB, ZA dash, ZB dash. So number of teeth on gear number A, number of teeth on gear number B, number of teeth on gear A dash, and number of teeth on gear B dash. So to determine the number of teeth on each gear, it can be seen that at stage 1, the speed increase, the input speed is 680 rpm. This should be the speed for gear A and B. The output speed from this stage has been seen from the speed diagram, that should be 340 rpm and 480 rpm, which would be the speed of gears A dash and B dash respectively. So from the structural diagram, or you can say here, you can find out here the 680 is the maximum speed, which is already we can find in stage number 1. So 680 and 480. So these two speeds are the output. Okay. Now the gear ratio can be calculated. First 680 divided by 680, you can get transmission ratio is equal to 1. Then 680 divided by 480, you can get a transmission ratio I is equal to 1.42. Okay, so based on this, you can calculate the number of teeth. The gear pair A and A dash and B and B dash to lie on the parallel shafts. The sum of number of all the teeth on the both should be same. This is a condition which we have discussed in a theory lecture, second theory lecture. The largest, and this everybody please note down, this criteria must fulfill in each design. The largest gear ratio in this case should be for gear A and A dash as per the figure. Hence the number of teeth on these gears should be determined first. As a transmission ratio between these two gears A and A dash is equal to 1. So ZA dash is equal to ZA. So the total number of teeth on gear A is equal to total number of teeth on gear A dash. And in B and B dash, the transmission ratio is 1.42. So B dash, ZB dash is equal to 1.42 ZB. What is the condition? ZB plus ZB dash is equal to, must equal to ZA plus ZA dash. ZA dash is equal to ZA. So ZA plus ZA, that is a twice ZA. And ZB dash is equal to 1.42 ZB. So we can find out the ratio between ZA and ZB, that is 0.826. ZB is equal to 0.826 ZA. Now the integer value of the number of the teeth on gears of stage number 1 can be calculated by using following for table. In simple table, we can use these empirical relations. So Z1 is considered as a 20. You can start with the 18 also. Okay. So as we know that ZA is equal to ZA dash. So ZA dash is equal to 20 number of teeth. So correction ratio, no, there is no correction. There is a directly standard ratio, 1 is equal to 1, which can be achieved. So the total number of teeth are 40. Now about ZB. ZB, if we calculated, ZB is equal to 0.724 ZA. So that can be calculated is 14.48. which we need to modify it because minimum number of teeth on any gear is required are 18. Okay, so the ZB we are considering is equal to 18. So based on that, you can calculate the value of ZB dash, which is 1.42 into ZB, which we found is 26. Now here the correction ratio we need to calculate. So actually the ratio should, because the total number of teeth are 44, as we find out the total number of teeth are 44. Okay, so correction ratio that is 1.44. So transmission ratio जो आने वाला था वो required था 1.42, but because of conditions we have found out the value of ZB and ZB dash, which is again gives the total number of teeth of addition of or summation of both number of teeth are 44. And if we calculated 26 divided by 18, what we get, the reduction ratio is 1.44. Okay, now choosing of ZA is equal to 20 as it gives the negligible deviation. Okay, so the correction between these two is negligible now because it not the transmission ratio was 1.42 and it gives 1.44. Okay, so here the flow chart for stage number 1, which is indicated as the motor gives the power 1500 rpm, initial stage from first shaft motor to pulley, it can start with the 1500 rpm, which converts into 680 rpm. For first input shaft, what we get, how much speed is received, 680 rpm, 680 rpm. Now 680 rpm will divide into two segments. So here the input is 680, here the input is 680, but output will require one 680 and second 480. Okay, so the transmission ratio for that it is 1:1, and it is we needed 1:42. Okay, but in actually what we get 1.44, that is a deviation. Now in similar manner we need to decide number of teeth on gears in stage number 3. So as we know that the number of spindle speeds we can